Hi everybody, welcome to the code and functional walkthrough of IRIS AI Studio application. So the objective for this video is like I'll walk through the code and I'll walk through the functionalities and talk through a few examples for each of the capabilities. This is not meant to be like very polished or like very short video. I'll casually walk through um, more like sharing it with a peer or something like that. So yeah, I'll kickstart with a quick intro. So in case you haven't seen the previous video or read the blogs. So there are two core components. So one is like connectors and another is playground. In connectors, you will be able to load data from different sources and convert it to embeddings and store the embeddings into the IRIS database. And from the playground, you have the semantic search or chat engine or recommender or similarity, through which you can retrieve the embedding contents back as something which is meaningful, like a text or a score. You'll be able to retrieve that back. So this is a very high level flow chart. Now let's start with the code. So here the code structure lies like this. In the backend folder we have the Python code, so it's written in Python Flask. App.py is the entry for this. Requirements.txt has the requirements. Utils has the utility functions. Other files we'll walk through once parallelly with the functionality. And the front end is written in Vue.js, and I have used Tailwind and Flowbyte for the UI components. So here inside source components, you'll be able to see the files. So upload options, we have 4 upload options. Each of them are put into these files. App.view is the entry for the front end, and views has the 4 different pages: the home page, connectors, playground, and settings that we have. And what else? Vercel, like I have hosted the front end on Vercel and the back end on Render. So the back end is like very tiny instance. You should be good to do some minor checks through the live application. So the link for the live application is over here. Yeah, irisaistudio.versal.app. And this is the README. We have some disclaimers that not to put any sensitive information in the live demo. And here is the tech stack. And these are the credentials for the local Iris instance that gets spinned off as I get started. And if you want to individually run the front end or back end, here's the code and this is the code structure. So now we will, yeah, so this is the script that runs when I try to run. So if you are cloning the repository, so you just need to do this one thing, like just need to run this single script. So what it does is, in case the port is already running, it will kill that and then clean up the system and then run the docker compose, which will clear, which will start the Iris local instance and the front end and back end code. So I'm just running ./build.sh. So it picked up the container which was running already and it started the front end over here and back end is running now. So the application is running. So I'll go to and localhost 5173. So yeah, now this is the front end. I just put the flowchart for anyone who is new here, and few FAQ questions which answers the generally asked queries kind of thing. So first we'll start with the configuration. So settings page. We'll delete the existing instance and create one from new. So as we could see, no active instance. I'll go ahead and add instance here. So I can name it like demo instance. And so we saw the credentials right in the README. I'll just copy paste that. So demo localhost. So you can also add any of your dev or like your playground instances that you have hosted on like AWS or Azure or GCP. So I have personally tried with one instance that was that I spinned off in AWS, and it was working seamlessly. So it shouldn't be a problem like connecting this with either your local or with any of the hosted instances of Iris. So yeah, so I'll show where these information is saved. So in the front end, so in the local storage is where I save the instances detail. So what all instances are there, and which one is the active instance. Say if I create one more instance 2, I'll just put demo incorrect, I'll just put something just for sake of creation, I'll just put, so whichever one is active it will change here accordingly. So now the active is the incorrect one, so it gets updated here and it gets updated here also. So yeah, this is where I'm saving local storage. So even if you leave this page, I mean, this will be in your local storage, and unless you clear the cache or cookies, this will remain as in all the instances that you have saved. And the API keys I have, I'm saving it in the session storage. Since it's comparatively critical, technically I should be saving both of them in an encrypted way, but this is just for exploration purpose. I have started this concept, so I'm just saving this in the session storage, so that once the user closes this tab, this keys also gets vanished. So it has just for some minor safety purpose. So yeah, we could see the API keys getting saved to the session storage. So this is how it's been done, and you should be able to delete any of the instances as well. So I'll paste my actual API key. Okay, so now I have added my instance, I've added my API keys. Pretty much this is the configuration that is needed as a user who is trying to use this application and explore the Iris embedding capabilities. So now once the configuration is done, we'll go to the connectors. So connectors is where we could load the data and get it embedded and save into the Iris DB. So I click add connector. So I have 4 different options. In one of my previous video, I have shown a local storage loading. So for now, I'll go with the Airtable loading. So I have one good or at least decent example to showcase the thing. So I'll paste the API key, base ID, and table. Okay. So now it asks me which indexing type. OpenAI Cohere. I'll go with OpenAI, probably with the larger one, 3072, and then I'll give Airtable sample. So the table we're creating is Airtable sample, and I'll go ahead and click next. So now it's getting loaded into the, so it says successfully loaded into the Iris. Now I'll go to the DB viewer. So I have set up the local instance here. So the SQL user, I should be able to see the newly created, yeah, data underscore Airtable underscore sample. So we gave the name as Airtable sample, but it got data underscore prepended. So that happens because of one of the libraries, Llama Iris library that I'm using. So even during the retrieval, we try to skim it off, like whatever the table names we are taking. So I'll talk about it. So now we'll see what information has been added to here. So it got the text content, and it created different nodes and the embedding values also. You can see it over here. Yeah, so this is, now we have the content in the Iris DB. We'll go back and see the code for this. So when it comes to front end, from the connectors page is where the page where you saw like 4 different options were there and you were able to give it, right? So from the connectors page is the views, and it loads the load data component. And from the load data component, we're having conditionals to load the concerned upload options. If it is Airtable, it will load the options from here and then send the data through event bus to the actual main file. And yeah, pretty much quite straightforward things. So, and also based on the stored and active instance that we are storing in the local storage, so that we are picking up to send the request. So a typical API request will contain all this information: the username, password, hostname, port, and whatever related to the DB, and whether the load type is local or S3, because based on this, the values would also vary, right? like whatever the credentials is needed for AWS or Airtable, that also we are picking up and sending it to the backend. So now coming to the backend code, so data loader.py, that is the file that handles this. So here we're getting all the basic information, and we're setting the API keys based on the indexing type and what type of loading we are seeing, and based on that we are reading the file contents, and then using the simple directory reader from the llama index is the library that I'm using to read the files. And then once we have these data loaded into the documents variable, then what we're doing is we are storing this information to the vector store. So this iris vector store is the llama iris is coming from the llama iris library. So so temporarily I have made a clone of the library because the versions was not supporting. So I have to use one of the latest version to support with one of the modules that I was using. So but ideally I would be raising a PR, and then we'll be using the actual library, then making a clone of it. Coming back to data loader. So yeah, so here we are giving the connection string, that is the DB iris DB information, what table we are loading the data into, and what is the embedding dimension of that. So this information is same as like whatever the model we are using. So that model's dimension will be giving it over here. Means like for say if you're using 1536 as a dimension for OpenAI's like smaller text embedding model, if you're loading that information into a table, so any incoming information to the table should be of the embedding 1536. It cannot accept any different dimension. So yeah. And then I'm setting like which model it needs to embed it on. So currently there is OpenAI and Cohere, but we have scope to add as many different models as we want. And that's comparatively easier because setting up the structure would take comparatively a longer time than keep on adding different models or different options into the system. And then yep, so here this is where we are storing the information, like which documents content goes into our DB. So and the documents get successfully uploaded, so we get the result in the API response. So pretty much this is how the data loading part works. We have different options, and based on the options we fetch the file, and that file we convert as embeddings and then store that embeddings into the iris DB. So we saw this complete flow. Now yeah, now we will go to the okay, we'll just quickly have a look on what data we did load from Airtable. So this is the data that we loaded from Airtable, the link that we just took. So this contains a few product names and the description of the product, and then a category, a landing page image of the product, the link, and when it was updated last. So yeah, so it has like 42 different products. Now this is the information that we have loaded, expecting that whatever we ask regarding this information through our retrieval engine, it should be able to give a good answer. So simply putting in a different word, this data is stored in a quite embedding way into the iris DB, right? So we are trying to retrieve the content out of that in different channels like semantic search, chat, or recommender, or similarity. Let's take an example. Hello Next. What is the description of Hello Next? So probably this could be one question. What is the description and category of Hello Next, right? Let's go to our thing, playground. Our table sample was our table. Indexing we used Cohere, and I think we used large. Let's ask what is the description of Hello Next product and which category it falls into. So it says description of the Hello Next product is understand your users' need and ship the right features fast. It falls into feedback management. Hello Next, understand, ship fast, feedback management, right? So this is one pretty simple example. So let's try to ask this. When was user report and recollective updated last, right? Updated. Which date was user report and recollective? updated last. Also give its day. So the day information is obviously not in the DB. So let's see if it is able to give. User report was updated on 20th, recollective on 19th. User report was updated on Monday and recollective on Sunday. So recollective 19th, right? Let's go and see. Recollective 19th and user report on 20th, right? So that's it's giving the right value, right? Let's try to ask one more, like more. So probably what can we ask? Okay, let's try to ask if, let's give the two products name and ask if both falls into the same category. Probably user testing and frill. User testing and frill falls under same category. Says no. We can ask explain. Let's see what it gives. User testing and frill do not fall under the same category. User testing falls under category of usability testing platforms and feedback management. I guess it's right. User testing, usability testing platforms, frill feedback management, usability testing platforms, right? So I think it gave a pretty, much accurate answer. So semantic search, you can think of like more natural way of searching something. So I think this is which will be much helpful for many different cases where we wanted more natural language search on top of the information that we already have. Just to give some more context, like here we embedded our information, right, from the file whatever we had. Also we can, whatever, say if you already have a DB, you already have the information, you should be able to run a small script through which you can create one another column that can store the embeddings, and you can store the embeddings of the another raw text column in as an embedding into that column. So you you can obviously go with the option of like creating a new table and then storing it there or something, but within the same table also you should be able to accommodate it, as long as your Iris instance version is like, I think 2024.1 it started supporting. I'm not sure, I have to check it back, but yeah. Coming back to, I think semantic search we explored it. Next we will go with the chat with docs. Add table sample, OpenAI, text embedding large, 2072. So now what can we ask to the chat? I wanted to see if I can ask something which can have that continuity in the conversation. So give all the products that fall under customer experience or no feedback management. Give the name of all products in numbered list that falls under feedback management category. Let's see if it's giving a numbered list. Oh no, it gives only 2. I don't know why. Let's see. Let's try to ask it. Give the name of all products. Probably HelloNext and Feedbackly are falling under the same node, because of which it gave this. Let's try to reframe it in a different way. Search for all the products that falls under feedback management category. Hey, it says only 1. I don't know. Let's try to ask the same in the semantic search. Let's see what it does. Here also it gives the same. So this is something which we have to see, like what is causing this issue. Because in the DB I could see the as per embedding. So if you see Feedbackly It has feedbackly here, and yeah, I think it has feedbackly here. So feedbackly and hello next it's picking up. But let's ask for a different category and see. Customer experience management. Okay, it says undefined, means our API failed. Let's see. Okay, so access denied. I have been facing this issue quite a while as I was doing the development. I seriously have no idea, but as long as I just restart it, it starts to work. So yeah, might be I'm just overloading the DB. So a table sample, OpenAI large. What am I supposed to ask? Yeah, a different category, right? Customer experience management. Category. Oh, it is giving only 2. I think I'm able to get the point now. So in the back end, the chat llama. So the similarity top K values default is 2, I believe. That could be one reason, because let's see, if we ask this in the recommender, I hope it gives all. Give all the products. I'll give the count up to 10, and I think there are only 5. Okay, there are exactly 10 products. Let's see what it, in that case I'll just give 15. Let's see what it gives. Okay, the response wise it is giving only 2, but in the similarity wise, how many we got? 1 2 3 4 5 6 7 8 9 10. We got 10, and all of them, let's expand everything and then search the category name and see how it works. Okay, customer experience management. So including this, there are 9 instances, means there are like 8 times it's been retrieved. So what's the name for this? User snap, and okay, hello next is here. So one by one, I think it's able to retrieve to some extent, but give all, if I give 5 products that fall, let's see what it gives. If I give exact number, okay, if I give 5 products, it gives the exact value. If I give all, it is not giving. If I give caps all, I don't think it will give. Okay, it gave 3. I have 0 idea. So if we specifically ask, then I think it's giving. Give 10. If I give, I think it will return all 10. Repeat. Give 10 products that fall under customer experience. Okay, ask nicely to user report. Is it in the same order or something? Ask nicely is here. User report is here. So it's not in the same order, but somewhere it's picking up only 5. See here, I mean, this count also doesn't make a big difference. Let's ask the same thing in the semantic search and see what happens. Oh, here it gives only 2, even if I ask. Okay, again access denied. I have to restart it. Okay, now I have to large. Okay, irrespective of my number. Okay, 1 2 3 or 3 products. I asked 5, it gave 3 and it's explaining 3. Okay, cool. I think this is the case with like asking something retrieving, but I think the core problem here is probably it was not embedded in a right way. Like, I mean, since our table would have probably returned a JSON, it would, I think the reader, from the reader to loading into the DB, I haven't handled the case of trying to read the JSON and load every object on the JSON file as a separate row. Rather, I just passed it at a text content so that it's split. Like, the split is quite unusual. So you could see here, right? Like, it's not consistently, not every row is one product. Ideally, it should be that way. I think if it was that way, it could have retrieved a better result, I believe. But again, like, we are trying to retrieve based on the embedding and not the text. So whatever the result we are getting, we have to see how. I mean, we have to see the pros and cons of it. Yeah, that's obviously the goal of this application, right? Letting the user explore how good, or like what is the pros and cons and how we could fix that in the process. So yeah, I think chat, let's try to do one more. 3072, what we could ask. Description of user voice and Nura. And is, okay, we'll ask as a second question. Is Noura's founder name mentioned? User voice is a platform capturing, I think, user voice. Noura, okay, both the description it gave. We're asking if the founder's name is mentioned. It says not mentioned. Noura or user voice, out of 2 products, which has longer description? So I think this should at least understand, I hope at least it understands what 2 products they're referring to. So I think technically Noura should have the longer description, but it says loop 11. Do we have a product called loop 11 here? Okay, we have a loop 11 product. It does not have a longer description. I don't know why it shows. I think the link is larger. I don't know. If we ask out of user voice and Noura, which has longer description, let's see if it is able to pick it up. Noura has, yeah, so it's able to pick it up. Out of 2 products, choose of which of those 2 was updated on Sunday. Feedbackly was updated on Sunday. Noura was updated on, okay, it gave a timestamp, that is 19th. 19th is Sunday, as we saw in the earlier example. Okay, I see. I think to some extent minimally it's able to get the previous thing, but I don't think it's as seamless. Like when I say out of 2 products, it's not able to pick up Noura or let's see, if is it a Monday. If I mean, at least now I'm expecting it to understand if 19th is a Monday. Let's see what it gives. Okay, at least now it is able to pick it up. What day is it? I hope it's a Sunday. Oh no, it gave error. What error? Access denied error. Okay, I'm restarting again. Okay, but I think our goal of like trying to see if the chat version is able to understand the context of what we're talking about, I think it does a completely good job. So yeah, so now we'll go to the recommender. I think we already saw a recommender, but we'll just play around recommender again. So here, large 3072, and okay, I think I haven't walked through the chat code. Let me do that and then come back to the recommender. So in the chat llama, as you could see, it's pretty similar to the query llama, but we just use the chat engine instead of the query engine. And when it comes to the UI, I have used one very good um, front-end library called Deep Chat, which helped me to style the chat like more easily than the other thing. So that's why I think it's looking quite familiar, like a simple chat window that does the job. So I've used the Deep Chat to do the integration, and it adds the message every time whenever the conversation happens, right? So the messages get added, and that's been sent to the DB. So maybe we could see one example. I can show how the messages gets added for every query. Also, the charts usually handle the very basic things. Hello, how are you? Let's see. I'm here to ready assist. Yeah, so these basic things, it adds up. Um, what day is today? I don't think it has that. Let's see. Not able to. Yeah, I don't think this has that. So the idea is here, if you see the messages, right, I'm keep on adding the information, and then sending that information. So so the session has the previous, like whatever we are sending, right? So that the backend has the context, and we are uh, sending the required information and getting the text response, and then showing that response here. So yeah, coming back to the recommender. So I'll also walk through the recommender code. For the recommender, so you could see for the recommender, like the basics is same, getting the all the basic details like the DB related ones, and then the other configuration ones we're getting. And then so we have two different ranking LLM based ranking algorithms that that helps to fetch the relevant information and rank it accordingly. Let me close this, don't save. Okay. um, yeah, so in the Cohere rank we get the top n results, and then in the OpenAI rank we get the top n results. I should have actually made this temperature configurable in the UI, which I missed it out, and also this model. On a different context, I tried GPT 4.0, and it was quite the results were pretty good than 3.5 to some extent on what I tried. um, and yeah, pretty much the same. It continues with the query engine and then gets the result, and then the core thing what it does is it ranks the result and then returns that, which we are showing in the recommender page. And when it comes to the similarity, pretty same, having the filter on a similarity cutoff, and then the filtered nodes, and getting the results along with the score. So yeah, okay, let's try one example with the recommender. Let's use Cohere re-rank and see. Okay, let's use Cohere re-rank and ask the same query on give all the products which has feedback management category. Let's give 15 as a higher count. Okay, this also returns only 3. And if we go to similarity, and we see this, give 5 products on feedback management. Or the core thing of similarity is finding the similar products, right? Let's ask what are the products similar to Hello Next. Hello Next. Okay, now what? Okay, again the access denied. I will restart this. And then okay, it says some error, connection refused. I don't know. Okay, it picked up. Add table sample, OpenAI, large 3072. The query is similar to hello next. Score cutoff point to expecting a count of 10, giving enter. Okay, so ethnographic research, feedback management is a category. Okay, context map, hello next. Okay, it picked up hello next itself as a product because it's very similar, but I'm curious how it is. Another thing is having a higher score. Okay, because it has two. Okay, I think I got it. Because this has two instances of mentioning, and here it is mentioned only once probably, so probably that makes it more similar to this. But yeah, it's a quite good relation, I would say. So it's able to find the most. And here though there is no so let's see one last result. 0.229 is the cutoff here, right? So this is look back is the product name. So and we are searching to hello next. Let's go back and see if the category of hello next and look back is same or different. Hello next falls into feedback and look back falls into usability. Or if we see the description, you understanding what's keeping your users from succeeding, understanding your users needing to ship fast. So something like, I think probably it would have picked up the descriptions similarity between both products, and that could have made it get closer, like look following the look back comment. What is this product? Indemo. So Indemo has ethnographic research, human behaviors and experiences. Yep. It's pretty good to make the relation. I don't know even if it is picking up just the file. I think all the image URLs will be pretty similar, right? Just the user content something. So it could have made some sense with that also. So probably this gives me some thought on why we should clean the data and then load the information into the DB when it comes to especially this kind of RAG use cases. So yeah, I think we covered all different options over here, and this is the GitHub repository of IRIS AI Studio. So feel free to contribute, or you can raise issues if you have any. And thank you for taking your time and watching this through. I hope I have covered all the items that I want. Okay, future scope I haven't. So with respect to future scope, it's pretty simple. I thought this while starting this project, the objective was trying to build something which is quite lean and helps to explore the capability, right? With respect to future scope, if I could think horizontally, we could add some more possibilities, like some more retrieval methodologies, right? Like say image retrieval, like in image, if I give one image and trying to ask what is the 10 most similar images to this from a pool of like say 100,000 images. So that kind of image retrievals we can add it. Like currently it has only text. Image was in my scope, but due to time constraint I was not able to add that. So same way we could add more options in the playground, that is more that will help them explore that capability. This is more like a horizontal expansion. If you think about the vertical expansion, like say adding more indexing types of, or adding more connectors, adding more connectors related to the healthcare industry, or the other industries where the IRIS DB is already into operation. So we could expand into that state as well. So yeah, so in a long run I see like say every provider who has like Databricks or even the native vector DB providers, Chroma DB or Pinecone, even Neo4j, the graph database. So everyone is coming up with their own versions, and having something like a AI Studio would definitely help to talk to the concerned stakeholders and showcase the capabilities and let them know like, okay, this is how our solution works, and you could play around and try to find find the relevant ones. Or if you are already a user of InterSystem, I mean IRIS DB, who's listening to this, then I think it will be helpful for you to set up an internal playground within your system. I mean within your team to see where it is performing and where it is not performing, like what kind of things you could also build a data pipeline on top of this connectors to make sure the data automatically comes in, and you can check that out, or um, have some kind of um, tracing back the searches, right? Like tracing back the vector searches and seeing like how good it's performing. So all those things we could add on top of this base version, what I have came up with. um, so yeah, I hope it has a positive impact, and thanks very much for listening. I think it took almost 40-45 minutes. Thank you very much. Have a good day.